The third law is called the law of multiple proportions. This is again a very important law which was given by John Dalton in 1803. The law states that if two elements combines to form two or more compounds, the different masses of one of the elements combining with the fixed masses of the other bears a simple ratio with each other. I'm repeating again. If two elements combines to form two or more compounds, the different masses of one of the elements combining with the fixed masses of the other always bears a simple ratio with each other, and this helps us in a very big way to find out the different possible compounds which can be formed between two different elements. Now let me explain you this with an example. The best example is hydrogen and oxygen. They both combine to form two types of compounds. One is simple water molecule, other is H2O2 called hydrogen peroxide. Now in this, if we take these two compounds in this way, like ratio of hydrogen and oxygen, and let it be water and H2O2, what we find is what is the mass of the hydrogen in the first example in water? It is 2. And what is the mass of oxygen in the first one? It is 16. Now let's move to the hydrogen peroxide. What is the mass of the hydrogen in the hydrogen peroxide? It's 2 grams for 1 mole, definitely. And what is the mass of the oxygen in the hydrogen peroxide? It's 32. Now we have, from this data, it is very clear, we have the different masses of oxygen. That means, as per the definition, different masses of one of the element combining with the fixed mass of the other bears a simple ratio with each other. It means what? These two different masses of oxygen which are combining with the fixed mass of the hydrogen, they bears a simple ratio with each other, which is 1:2. Do you know this also means what? It means what? If the hydrogen is 2:2, the oxygen in the first case will be only 1, and in the second case it will be 2, as it is apparent from the given examples. So this is what is your law of multiple proportion is. Different masses of one of the element with the fixed mass of the other, they bears a simple ratio with each other. It's 1:2. Let us take one more example so that this concept of the law of multiple proportion becomes clear. We can take example of carbon and oxygen combining. We know that they form carbon monoxide as well as carbon dioxide. Now let us find out what are the ratios of the carbon and oxygen we have in case of carbon monoxide and in case of carbon dioxide. In the first case we have only one carbon, so it will be 12 grams for 1 mole, and since it is one oxygen, so it will be 16 grams for 1 mole. Whereas in the case of carbon dioxide, it's again 12 grams for carbon And then since there are 2 oxygens, it will be 32 grams for oxygen. Now you can see we have different masses of oxygen and we have fixed masses of carbon. If it is not there, we will definitely make one of the masses of one of the element constant, same, and then we will find out what the ratio the other masses have for the other element. Now since in this case this oxygen has a variable masses 16 and 32 which are combining with the fixed masses of carbon, let us find out what this ratio the oxygen atoms are having between the two different compounds. It's 16:32, which is again 1:2. That is why first molecule contains only one oxygen, second contains the 2 oxygen molecule. So this is what is your law of multiple proportion is. When two elements combines to form 2 or more compounds, the different masses of one of the elements combining with fixed masses of the other, they bear a simple ratio with each other. We can take one more example to make this again very, very clear to you. Like as we know, nitrogen forms many types of oxides like nitrous oxide, nitric oxide, nitrogen dioxide, dinitrogen trioxide, nitrogen pentoxide. This is nitrous oxide, which is also called laughing gas, nitric oxide, nitrogen dioxide, dinitrogen trioxide, and dinitrogen pentoxide. Now let us find out what are the different ratios we have of nitrogen and oxygen in this. Let us write all these in one line like this. And let us write down nitrogen and oxygen like this. So we can clearly from here we can visualize this nitrous oxide. There are 2 nitrogens, so it's 28 grams. Oxygen is 1, so it's 16. Here nitrogen is only 1, so it's 14, and it's again 16 because there is only 1 oxygen. This NO2 molecule contains only 1 nitrogen, so 14, because we know that mass of the nitrogen is 14. Oxygen says its mass is 16. There are 2 oxygens, so it will be 32. Here we have 2 nitrogens, so it will be 28, and there are 3 oxygens, so it will be 48. Here it is 28 nitrogen because there are 2 and 5, that makes 16, 5 is 80. So this is what we have. Now what is the problem in this case is we have different masses of nitrogen and though we have different masses of oxygen. What we can do is we can multiply this by 2, so it will make it what? 28. So here also we have to multiply it by 2. If this is also 28, we have to multiply this by 2 and this by 2. So this is how these all become what? 28. So they becomes constant. They will be variable. What they are? It is 16, 32, 64, 48, 80. So what is the ratio between these is? The ratio between these is, if we divide by 16, it's 1, it's 16, 2, it's 16, 4, it's 16, 3, it's 16, 5. So the ratio comes out to be 1 is to 2 is to 4 is to 3 is to 5. So this is the ratio we have of the different oxygen atoms and the different oxides of nitrogen.